Mhm.
Um, do you mind if after all of this, if I were to contact you again so we can
Absolutely.
interview you a little bit more?
I would be happy to talk with you about that and some of the stuff we did and what you might look into and help out. Yeah.
Yeah, thank you. That's amazing. Yeah, because my team is gonna be super excited then.
Mhm, mhm. One of the really cool things about working here is that, and a lot of this is not to say that working here is better than working other places, but when you work for some companies, your impact, you don't necessarily see it on the human level quite as apparent as you do here, because so many of the machines we build are designed to make things safer or make things more comfortable for workers. Um, when you go and you look at a machine that we're using versus the machine you designed and built and how much of an improvement it is, it's really quite rewarding to see how much the workers in the field are benefiting from the work you put out, which is something you don't necessarily get at other companies. And so I really like that sort of human, helping the human condition.
That's yeah, yes, I totally get that. That's so cool. I feel like I'll be saying that throughout the call. Mhm. Um, so I have a couple more questions that I wrote down and some that I think it was Dawn who put together. So I'll be asking a little bit more about that and the interests you had in high school. Um, and yeah, so that will be a little more about that.
Sure, perfect. Yeah.
So
I'm gonna go.
Leslie, just a quick question. Are you or are any of the three of you going to be monitoring the Q&A in the chat bubble or when it's that time, or do you need me to do that for you?
I was planning on monitoring it, but
Okay.
I additional help wouldn't hurt.
Okay, I'll just leave it to you and can assist a little bit if I'm needed. But everybody that's on today, this is webinar format if you haven't been on one of these before, so you're not seen or heard. If there are any teachers that are on that want to be promoted, I did promote Zachary. Feel free to use the raise hand feature and I can move you over here. Also, you won't be able to unmute or turn your microphones on, and please put your questions in the Q&A chat bubble and we'll monitor those. Yes, I know some will be coming in late and some will be leaving early based on their class schedule, so that's perfectly fine. All right, Trevor, for time's sake, I'm going to go ahead and let you introduce yourself and we'll get started.
Okay, well, welcome everyone. I'm so thrilled to be here with you all and looking forward to talking about GK Machine, what we do and what life here as an engineer is like. We have a moderator, Leslie, who will be answering or asking questions that you guys have at the end of the presentation. So go ahead and type those in the chat. She can record them down and she'll have some questions to ask as well. So let's get started. I'm really excited and I hope you guys find something interesting in the presentation today. So like I said, my name is Trevor. I'm a mechanical engineer at GK Machine and this is where I work. This is GK. We have been manufacturing agricultural and industrial equipment for a number of years. We build all kinds of things, big and small. We serve all kinds of customers, big and small. And it's really quite an amazing and diverse place. Lots of different types of engineering and design go on here. To give you a brief sort of history of GK, it was founded by brothers Gary and Keith Grossen in 1976 in their family barn. So that's where the GK and the G and K comes from, Gary and Keith. They started by repairing tractors and farm equipment, and then they started customizing it for people upon request, and then they started building small pieces of equipment, and pretty soon it just kept growing and growing to now we have about 180 employees and 177,000 square feet of manufacturing space underneath of our roofs. We have even more yard space where we do testing and we have other equipment. So it's quite an operation. We build our own equipment that has the GK logo on it. So this is an example here, this photo, it's a 3-wheeled sprayer. This sprayer looks a lot like many crop sprayers you'll see in other parts of the country, but this one's unique to the Willamette Valley. It's a lighter weight machine designed to be used here where it rains a lot, the soil is softer, the crops are more fragile than other places in the country. This is an example of our branded product. We sell a number of different types of GK branded product, but we also sell and build a lot of product for other companies. So there are companies that have designs or ideas for machines they want to sell or products they want to build, and they hire us to go ahead and design and build them for them. And so we provide that service to a number of companies. So here's a video kind of discussing some of what GK does.
GK Machine has been growing now for 40 years. From the simple beginning of repairing tractors and trailers to a world-class manufacturing facility, we have made it our business to grow. We now have over 175 employees working in 4 different product areas: agricultural products, greenhouses, custom equipment, and contract manufacturing. Let's take a look at some of the work that goes on here at GK Machine.
We here at GK have a lot of opportunities to work with your hands. So if you have a good work ethic, you're here on time, there's lots of things that you can do to advance yourself throughout the company. You can start in the assembly side of it, putting things together. You can start with the laser tables, breaking out parts, marking parts, doing the quality control. There's just a lot of hands-on jobs here that are available throughout the company.
We could build anything in this place, and every year he got better and better at it. One day we're making locomotives, the next day we're making sprinklers. It changes constantly around here, and that's why I like working here, because it's fast-paced and something new all the time.
What I find interesting about GK is it's located in this small town of Donald, in seemingly the middle of nowhere. You could almost drive right past it, but as soon as you go through the front doors, it's hard to miss all of the technology that's just thriving inside the buildings here. You'd think that it's just a few welders and some assemblers, and they're a big part of our workforce, but there's also lots of engineers, lots of administrative staff that's helping manage the projects, IT folks such as myself that are maintaining the hardware and making sure we're taking advantage of new technologies.
GK is a great place to work because of their family-oriented philosophy about the community and their employees. They treat everybody like family here, so it's a wonderful place to work.
Yeah, GK looks at the person and their work ethic and what they want to do, and we try to match them up and place them in positions where we feel that they will thrive.
GK is really heavy into the technology. We'd like to be the leader. We have won 9 world awards. They take the top 50 engineers of the world. We've been there 9 times.
An important ingredient in our success is our employees. We have painters, welders, machine operators, laser cutters, engineers, salesmen, accountants, and many other positions. Our employees have many skills and a lot of passion for what they do. Working together, we build the products that serve our customers and help them to succeed. We believe that we can build anything that our customers can imagine. What can we build for you?
So that was a little bit of a sales video. I apologize, I don't have anything tailored for this presentation, but I think you get the idea looking at some of the different departments and the types of things that are going on in here, just how an engineer might be involved in helping facilitate some of those manufacturing processes. So let's go ahead and take a look at some of the equipment that GK builds. This is the photo here happens to be a 4-wheeled crop sprayer. It's articulated in the center like a bendy bus. And it's used all over the Pacific Northwest. Here's some other equipment, just to give you a diversity here. We have a crop sprayer, fuel tanks. This is a land leveling thing. We've got all kinds of different sprayers and tree diggers, different agricultural implements and equipment. Down below is a strawberry harvester, the green machine at the bottom. And so if you ever eat strawberries that you buy at the supermarket, there is a very, very, very good chance that it was harvested with one of those machines right there. We also have a whole line of nut harvesting equipment that we, in the last 5 years, have designed and built and brought to market. So you can look out in the valley as you're driving around, look for this equipment. And looking at these photos, you can kind of get a sense of all the sort of different size, scale, and types of mechanical engineering that goes on in these things. We have machines that use engines and have wheels and powertrains. We have machines that don't have any mechanical, diesel or gas engines on it. It's all just simple mechanical linkages to do things. So there's a lot of diversity in the type of design that goes on here. We also build, like I said before, custom equipment, and we build products for other brands. So here's some examples of that. This is a tomato harvester and a blueberry harvester. There's an engine there that is, we build a lot of those types of engine skids, power packages for use in ships like cruise ships and fishing ships. At the bottom left there, that's a sod harvester. So if you ever go to the store and, like Home Depot, or have a landscaping crew roll out sod in your front yard, it was harvested with one of those machines. And just all kinds of different things. The center picture there, that's actually the front of a train cab. One of the projects that we worked on a couple times was making custom locomotives. So really, it runs, there's a very large different diversity of things that we do. There's also a lot of stuff I can't show you, unfortunately. Very large scale industrial equipment used for specific industries. The robotics and autonomous vehicle stuff is something we've been working on for a while with lots of different customers. And unfortunately, that's all fairly new and high tech, so I can't talk about that at all today. But robotics and vision systems and finding ways to make things autonomous or semi-autonomous is a big part of the agricultural technology space nowadays. And so this is something that if you go into an industry like GK is in, you're going to find that you'll be working in a lot of areas where you'll be doing sort of the old school engineering, where it's, big sheet metal that you're welding, and then you'll also be doing some of the high tech mixed right in with it. So it's quite interesting. And to give you a sense of scale for how big some of these machines are, you can see here there's a person sitting next to, kind of a big box, and that box represents the size of some of the machines we build. So it's really quite something that I love coming to work. So what do the engineers do when we're designing these different products? go ahead and type some ideas in the chat, because I'd be curious as we're going through to kind of see what, what people think. But let me go ahead and play another video for you guys. And this video is me before I got a bald spot. So, that's a bit embarrassing, but this is more of a sales video, but I hope you can kind of see through the sales part and just kind of look at what we're doing, what we're talking about, what's on our computer screens, what kind of equipment we're working with, and get a sense of what are some of the things that engineers are doing. And what I should say is that the biggest thing we do, and this is true of any engineers, we solve problems. We are looking for solutions to problems that customers have, or even during the design phase, you're trying to fit puzzle pieces together and solve problems. So with that being said, go ahead and take a look at this video. We have a very diverse team of people here, engineers with electrical experience, hydraulics experience. We design our own control systems and manifolds. My name is Trevor Sheck. I'm a mechanical engineer here at GK Machine. We've worked on projects for the Navy, for marine industries, for train and locomotive applications, clients that are small, large, farmers who come in off the street. One of the things I love doing as an engineer is working with a customer to bring solutions to life. We use 3D computer-aided design software, finite element analysis, mathematical analysis software. Oftentimes customers will come to us with a problem and not really have a clear idea of how they can solve the problem. But when we work with them and we form a team and we come up with a solution, it's really rewarding to see that solution come to life right here at our own factory in front of us. One of the advantages of GK is that we have everything here. We have the engineers here. We have the manufacturing here. We have everything you would need to bring a product to life here on site. We are comfortable doing pretty much everything. One of the really rewarding things about working for a company like GK is that you can really have an impact on people's lives. We often say here at GK that we have touched your life, because so many of our products are used in the agricultural industry to grow crops or raise crops, harvest crops that you buy at the supermarket. Okay, so a brief video, but I hope you saw in there some of the what some of the engineers were doing in the background there. And so let me walk you through some of those things in a little bit more detail. Well, I think the one that everybody thinks about nowadays is CAD modeling, computer-aided design. So making 3D models of things, right? And that's actually sort of, I like to think of CAD modeling as the tool we use to create our designs, because the designs still have to come from a place of, our creativity, our intellect and understanding problems and things like that. So the CAD is really a tool where the skill set of the engineer comes into play is important. And that's the understanding of your customer and what they want, understanding the problem, being able to critically think, being able to communicate and be a team player and all these kinds of things. But this is an example of what CAD modeling here at GK might be like, and at other companies. We start here on the bottom left with, a sort of a sketch, a bunch of sketches of a radiator shroud. So this is a fan shroud for the radiator inside of a nut sweeper. And then we can create some surfaces to kind of get a rough idea of what it looks like. And then from that, we start designing the sheet metal and what a sheet metal part might look like, where we bend it to make the shapes we want and weld it. And pretty soon, if we do this for all the parts in the machine, we actually have a fully assembled in 3D model of a machine. And what's really useful about CAD design nowadays is that because you have a fully 3D model of everything in the machine, you can do all kinds of analysis on it. You can pretend like you're turning the wheel all the way to one side to see just how tight of a turn it can make, or you can, twist the frame to see just how much, suspension travel you have, all kinds of things like that. So CAD is a very useful tool. As part of that, there's a lot of analysis and mechanical design we do as part of our design. So I won't get into a lot of detail of the specific tool sets, but we do things like the center image here, the one that's colored. That's something we call finite element analysis. And what this is we actually sort of simplify the CAD model down into basically a number of different small links, and we simulate what the forces and the twisting or the torque or the pressure, the different types of things that are acting on the components to see where the stress, where things are going to break in a design. We do a lot of math at times. Math is not as, calculus isn't as important, on a day-to-day basis as maybe some of the movies make it out to be. However, it's really important you do learn that stuff because it sort of trains your brain into a way of thinking about things, about how to break big problems into smaller discrete problems that you can solve and how to think critically and so on. We do a lot of different types of simulations. Everything around you in the built world, there's some sort of math, some sort of critical thinking, some sort of analysis that had to go into designing it. We do a lot of hydraulics and manifold design. This is a topic that sort of bears it requires its own presentation just to kind of explain some of it, but you can kind of think about hydraulics as basically compressing a fluid, in our case oil, and then being able to move that fluid throughout a machine to turn motors, like turn wheels or like extend actuators and do work. So we pressurize the fluid and then we direct it to different places to do work. And in order to direct it and to control it, we have to design these systems that have sensors, have all kinds of transducers and valves and electronics. So it's really quite something. And I noticed there was a question here in the chat about what software we use. Here at GK, we use Inventor for our 3D modeling, and we use AutoCAD for our 2D schematics. Every machine has all kinds of different systems that interact with each other. So we have people that specialize in electrical systems design. There are computers and sensors and all kinds of things like that. But because we're building farm equipment, we can't just put an Arduino somewhere. We need to have electronics that are robust, that can take a lot of vibration, that can be exposed to water, and all the different wire connections and how we route the wire so that we make sure that it doesn't break, it doesn't get torn, it doesn't wear. There's a lot of people who specialize in understanding the best way to achieve these tasks of installing computers and sensors and control software in machines in a way that they don't break down in a really rugged environment. We have people that specialize in understanding welding. That's a very big part of what we do is taking metal and welding it together to build frames and structures. And there's a science of metallurgy and physics that are involved in that. And then we have people who are really good at drafting. Here at GK Machine, the engineers are also drafters. We don't sort of separate the two. Some companies do. Some companies, they'll have design engineers and then they'll have people who specialize in drafting. But regardless, drafting is a skill set that's important because it's what communicates your designs to the shop floor personnel who are building it. So you can design a 3D model, but you have to find a way to accurately communicate that to them in a way they can build it, right? And so that's what our drafters are doing. We also have people who specialize in manufacturing design. So these are people who look at the designs and determine the best way to make those components, those parts. They also look at ways of the best way to communicate, the best way to give information. So it sort of runs a very large range of things they do, from everything from determining the best way to fold metal to get to a specific shape, to how you set up all your CNC machines, to what kind of jigs and fixtures you design so that when you're fabricating or welding together parts, they all fit together every single time you do it. So these are some of the important skill sets here. And, I've kind of walked you through a number of the different engineering areas, and I know you've already seen a few videos, but I'll play one more here. And this is really kind of showing the life cycle from start to finish of one of our products moving through the factory. Again, it's a little bit of a sales video, but I hope you can, as you're watching it, you can see all the different work centers and the manufacturing that's going on, and think about what an engineer would have had to understand and figure out, to use each one of those work centers to build this product. So this is an irrigation hose reel, what I'm going to show you. These are used to run big sprinkler systems and irrigation systems in crop fields, and you'll see them throughout the Pacific Northwest if you drive around. Next time you're driving around crops, look for a big yellow machine that looks like this. And oh, I skipped a slide. I apologize. So these are the work centers that you're going to see in this video that I'm about to play. Metal cutting with lasers, plasma cutting machines, and using flame to oxidize metal to cut it. CNC machining. So this is where computers control the actual machining that's happening. Metal forming, welding, sandblasting, and acid washing the materials before we paint it, and then using different types of painting technologies. And then obviously, just the assembly part of it. So those are the things you're going to see in this video. And here's the hose reel I was talking about. So next time you're driving around, look for it.
When GK Machine designs a new product, we start out with some rough sketches and talk about the requirements for the machine, the basic functions that it will perform, and items like the target cost and the raw materials that will be needed. Once we have a basic idea of how the product will work, we begin to create the computer models and blueprints that describe all of the components. These will be used to program the machines that cut and fabricate the raw material. We have some of the most advanced material processing machinery available at GK Machine. Along with some classic tools like metal saws, press brakes, punches, and rollers. Welders play a big role in building the major components of our machines. We have giant rooms for powder coating and painting that allow our painters to coat all of the parts and assemblies before the product goes to final assembly. Trained employees who know how to efficiently and accurately assemble the very complex machines work hard to build a quality product. When all of our work is done, the product is ready for delivery to a customer who will put it to work. As our employees begin building the next machine, we take pride in knowing that we are having an impact on the lives of our customers.
Well, I hope you appreciated seeing all the different work centers. We're about to wrap up so we can get into the questions and answers, but I wanted to just share with you guys something that engineers, the fundamental thing is we have to be creative. We have to be creative problem solvers, and we have to be creative in how we design things. And so it's oftentimes, this sort of stereotype that engineers can't be artists, they're not, that creative, but we are actually. We can be artists. And this is an example of an art piece that we designed and built. So this is actually located at the State Fairgrounds. If this is a map of the State Fair, when you go, you kind of walk around. Right there in the center of this fairgrounds is what's called the Spirit Tower of Oregon. And this is it being built to give you sort of a sense of scale. And I could talk at great length about the engineering challenges in designing art like this. You have to figure out how do you make all the different pieces fit together correctly? How do you make it aesthetic, but also manufacturable? Just the planning of how you build something this big is an engineering process in and of itself. But the finished tower is, you can see here on the left-hand side what it looks like. Here's a bigger photo. And each of these legs represents the past, the present, and the future. So you kind of have me as a present engineer on the phone, but you guys are the future of engineering and other fields here in Oregon. So keep that in mind. Engineers can be artists, and also we look forward to working with all of you guys in the coming years as you become engineers. So with that being said, I'm going to go ahead and end me talking at you and have Leslie start asking some questions. I do actually have another engineer who's come and joined me. So you have a perspective from a couple different engineers. So we're going to do a little bit of a handoff here. I'm going to have him sit where I'm sitting, and I'm going to join on my phone so we can be socially distant in this odd time of COVID. So thank you all, and stand by for questions.
That is amazing. Thank you so much, Trevor. Just hearing everything you get to do at your job, and as an aspiring engineer, it's very, I'm just very excited to be here and ask you questions. I know you guys are getting settled down, so I'll give you about a minute.
I have to stop sharing the screen. Okay. Jacob is plugging in his headphones at the moment. But in the meantime, Leslie, go ahead and start asking me some questions.
Yeah, so my question for you guys is, what experiences growing up or in high school motivated you guys to become an engineer? I know for me, it was an after-school engineering club. So I'm excited to get to know what motivated you.
I don't know that I was necessarily motivated to become an engineer. I feel like my personality type was that I was going to be an engineer regardless. But I think what motivated me to pursue that was probably my desire to help people and solve problems. That's a big part of who I am. And engineering allows me to do that.
Well, that's so interesting. And I know, Jacob, I'm interested to hear your story.
Oh yeah, sorry, I was just plugging in. So what was the question there?
Yeah. So what experiences throughout your life or the high school in particular motivate you to become an engineer?
So I kind of grew up in a farming agricultural background. So probably the biggest thing that shaped that was just growing up, working on the farm, working on equipment. I really enjoyed working with my hands and problem solving, because that's something that comes a lot with farming and that sort of thing. So that was probably the biggest one right there. But then also being involved with programs in high school of, engineering, kind of head start type programs, that sort of thing, getting to do projects like that. Any things like that were definitely probably the biggest influence, I'd say.
Yeah, and if you don't mind me asking, going off of that, what programs or what clubs in high school were you a part of that encouraged you to go on to this field of agriculture? And Trevor, kind of like a follow-up question for you. What motivated you to work at GK Machine in this industry? I know Jacob mentioned about his past with agriculture, so I'm interested to hear about yours.
Sure. Well, I took a tour of GK Machine, and so I was really impressed by what I saw, and I needed a job at the time. So I reached out to the owner of the company, to one of the shop managers, and said, hey, I'd like to come work for you guys. And they brought me in for an interview. And that is actually a lesson for a number of people. Every job I've ever gotten that I can think about, I got because I took the initiative to go into the place, call and find out who I should talk to, that kind of thing. I didn't just submit my resume on an online portal. And I think that's been very successful for me, and I think that's something people should keep in mind. But that's how I got the job. The reason I stayed at this job, because like I said, I needed a job at the time. The reason I stayed here is because of the ability to create and build machines that are frankly very cool and that have a big impact in the industry that they're going into. I like seeing problems being solved.
I like that. I like problems being solved. Thank you. And how about you, Jacob? I know you mentioned about your background. So what programs in high school were you a part of?
Trying to remember now. There was a couple couple of robotics programs, nothing too crazy, but just kind of, starting out the basic, a lot of those Lego Mindstorm type stuff, robotics competitions, that sort of thing. I think it was some sort of STEM program that my high school had for that. And then also as well as, we had one that was building like a race car, go-kart type thing in high school. And then we took the competitions and that sort of thing. That I believe that was through the American Society of Agricultural and Biological Engineers. I can't remember for sure on that one. But yeah, those were a couple of programs that definitely I was involved in that made a difference.
Leslie,
Wow.
I don't mean to interrupt, but I do see that there was a question asked about the role of women in engineering. And what I wanted to just address that although unfortunately you only have Jacob and me here today, we actually do have women engineers working for us. And I think that it's a good thing that there are more women involved in engineering now than there used to be. And I would certainly encourage people to continue pursuing that. It's unfortunate that it has been so male dominated for many years. Anytime you have diversity, regardless of whether it's gender, race, economic background, what your personal life experiences are. For example, Jake grew up as a farmer. I grew up doing a lot of other different things. We all bring sort of things that give us insights to be better and be more creative, make the team better.
That is so encouraging to hear as an aspiring female engineer. And moving on, as you mentioned from the Q&A box, any of the students that are on this call, if you have any questions, feel free to put them in that box and we'll be trying to answer them right now live. So moving to my next question is, what were some difficulties from the transitions from high school to college and then from college to the workforce?
Well, I'll take the high school to college one and I'll let Jake answer the other one. For me, I actually had a fairly difficult time in college, and it wasn't because I wasn't smart. I don't mean to sound egotistical, but I am smart. And it wasn't that I wasn't smart enough to do well in college. It's that I wasn't used to having to work hard, and I didn't know how to study properly. And there were a lot of different skills that are important in college that I didn't really develop as a high school student. And I think I entered into it with this expectation that it would be like high school. And I don't say that to scare people, because you should absolutely pursue college if you're interested in it. But I think what's important from my own perspective is that I was unwilling to ask for help. I felt ashamed to ask for help, and that held me back. And I think that as I've gotten older and I've worked with more people, I think we all suffer from that a little bit. And I think it's important that when you do go to college, you be willing to ask for help. And when you're at your first job, you have to be willing to ask for help.
How about you, Jacob?
No. So first, I am 100% exact same thing as what Trevor said. Most engineers obviously are fairly smart people. And so a lot of times high school can be kind of almost a little too easy, and you don't have to quite apply yourself like you do in college. And so that can be a really tough one. That it's really common. A lot of people talk about that once they get through college and that sort of thing. So that's a big one. But then, like he said, I'll, kind of cover going college to real life career type situation. Honestly, it's just kind of, you have to kind of learn your place a little bit. There's everyone at the company has a role. And so when you start out, you might not be doing as many of the most exciting projects, and it's something you kind of have to work up to. So that can be a tough one at first. You think, oh, this is boring. I'm just doing all this kind of entry level stuff, but it's, you have to get experience. There's a lot that you won't learn in college that you learn, just by working and that sort of thing in real life. And so just, kind of getting through that and getting caught up and, into the pace of real life career and job and that sort of thing. Definitely takes a little bit of time to get used to, but yeah.
Oh, that's so
And
interesting. And
one last thought that I wanted to share. Earlier in the presentation, I talked about the importance of critical thinking and that, taking calculus and these things are important for developing that, but that we don't necessarily use it every day. I think what's really important is if you are a driven person who is creative and good at problem solving, that matters more than the GPA you have. So don't be intimidated to pursue engineering just because you're worried the classes are going to be a little bit hard.
that is so motivating. And on the topic of college and things like that, someone in the chat asked, what colleges did you guys attend? How about you, Jacob?
So I went to Purdue University. That's in Indiana. I originally from this area out here in Oregon, but I grew up most of my life there. So I went to Purdue, studied agricultural engineering, specializing in machine systems. So it's a lot like a mechanical engineer type role, but we also get the ag side of it as well. So yeah, that was where I went, and Trevor can let you know about him.
Yeah, I am one of those odd people who kept changing their mind. So I actually, you know what I realized? You aren't seeing me when I talk this whole time.
Oh, I can see
Yes,
you.
we can. Yeah.
So I went to the University of California, San Diego, and I studied mechanical engineering. But before I studied mechanical engineering, I studied bioengineering, actually. And I thought I was going to go to med school. And I discovered that I enjoyed the physics, the mechanical part of bioengineering more than I did the medical side. Although I still am very fascinated with medicine. So yeah, it's not uncommon for people to have different interests and eventually kind of hone down into the one they pursue as a career. But I was also a musician for a while, so diversity of interest there.
I absolutely get that, Trevor. I'm in some ways like that too. And kind of to reiterate, did you guys go out of state for your schools, for your university?
Well, so when I went to Purdue, I was actually living in Indiana, back where I'd grown up most of my life there. So I was technically in state, and then once I graduated, then I moved out here to Oregon.
Oh, okay. What motivated you to move out here?
Just because I was originally from this area, I wanted to move back with family. Had farming opportunities out here, but then also I'd had an internship out here with a different company that we actually do a lot of business with here at GK. And so at the end of my internship with them, they had highly encouraged me to check out GK. They thought it'd be a really good fit just because of the work that we do here and that sort of thing and my personality. And so at the end of that internship, I came up to GK and got a tour, met everyone, and kind of thought, this place is pretty neat. And so I went back to college, still went through a lot of interviews and looking at a lot of different places. But at the end of the day, GK seemed like the best option for me, and moving back to Oregon was definitely a plus. So yeah, that was how I ended up here.
Okay. And how about you, Trevor? Did you go out of state?
No, I'm one of those people who moved up from California, actually. But I did come here with only $87 in my bank account. So I had to fight for a home, just like all of your parents.
Well, okay. So that's so interesting that you both came from from an outside state into Oregon, which it's still that's super interesting. And Jacob, you mentioned about internships, which is something that I am super interested in helping to do throughout my college years. And even now. So I guess my question is, how did you find such internships, and how was your application process? I know it's different for all of them, but how was yours like? And if Trevor, you have a similar story, I would really like to hear it.
Yeah. So I was honestly really lucky. One, Purdue's a great school, but they also are highly focused on internships and getting students into those jobs in the summertime. Pretty much, I had an internship every summer when I was in college. Every professor, every class I took, they all encouraged it highly. And so because of that, we had a lot of opportunities on campus that they set up for obtaining an internship. So we had career fairs. We'd have companies come in, especially in the ag engineering department. We were pretty well known and a small department, and so we'd have a lot of companies come directly to us in our classes. And so that was really nice. But the job fairs is a big one. I highly encourage anyone, when you get to that point in life, go out there, apply to a lot of different jobs, look into some things that maybe even you don't think you might be interested in, and learn about it. And maybe you aren't interested in it, you don't have to take it, or maybe you find out something that could be a really good opportunity. So yeah, I highly encourage that. Having a good resume, having all that stuff, always having one ready and that sort of thing, keeping it updated is important, because you never know when you might have that opportunity. But then also outside of the job fairs and all those, kind of typical ways of finding an internship or a job even, is making, contacts, networking, that sort of thing is really important. That's how I got, I guess, basically half my internships. One was completely just by networking. One of them was career fair, and then kind of actually got in with them because of the networking. And the other one was just completely a career fair kind of side thing. I didn't know anyone at that, but networking is huge. And so, make those connections, with, classmates, with professors, with companies you work for, and companies you work for through them, make all those connections, because they'll come in handy later. Definitely very important.
And how about you, Trevor? That's so interesting. Thank you, Jacob.
Mm-hmm.
Well, I certainly agree with everything Jacob just said. The other thing that is really nice about Oregon is that it has a fairly robust and developed internship program from at the universities. MECOP, for example, at Oregon State is a really good program. And the fact that the universities here want students and have programs to place students in internships is really good. Where I went to college, that didn't exist. We had to find our own internships. And unfortunately, I went to school in an area where it was very difficult to, there was a lot of engineering companies and even more engineering students. So it was a very difficult process, which is one of the benefits of Oregon. And I definitely think it is really, really good that you get an internship. But like I said about how I got started here at GK Machine, and like how Jacob said, that networking is really important. Don't just submit a resume online. Go around, knock doors, talk to people.
Yep.
Thank you so much. This is such great advice. We have a question on the Q&A box, which again, students, if you have any questions, feel free to type them in there. It says, what tips do you have for someone attending college? Which is something that I'm interested in as a senior. So how about you, Trevor?
Well, and I apologize, Jacob's mic keeps picking me up, and so you're not seeing my face. You're seeing his, so just pretend it's me talking. But I think that aside from being able to ask for help, I think one of the most important things about going to college is to really learn as much as you can from all of the experiences that you have there. It's not just about the classes and the homework. There's a lot that you're going to learn about teamwork and how to work on projects with other people and how to interact with people. A lot of students, they might be the first person in their family to go to college. And so, to be honest, there's a real issue with, people in that situation learning for the first time how to talk to people that are superior to them in terms of the organizational structure and how to converse and things like that. And I think those are all good skills to learn. And as far as doing well in college, I think the thing to remember is that there's a lot of distractions that you can have, but it's important to think about what your goal is. If you're constantly resetting yourself and recentering about why are you there and what is your goal, I think you're going to stay on track and you're going to do well.
Thank you, Trevor. And how about you, Jacob?
Yeah, definitely a lot of that. I'd say, make sure to, focus on what's important. It's not a bad thing to, jump around a little bit and try and figure out, what you want to do, because it's better to figure it out, the earlier the better. But, try and figure out, as soon as you can, what you want to do. That way you can pursue that and be efficient and effective at that. But then also, make those connections in college a lot, of people that they're people you're going to be working with. And so you need to learn how to work with them well. And then after college, they're contacts that you'll value and that sort of thing. Just, and make sure you enjoy yourself, but don't let that get in the way of, getting your degree and the real reason you're there. So,
Yeah, thank you, Jacob. And on that note, what is something that motivated you? Because I know that there might have been some rough patches throughout college. So what motivated you to keep pursuing your engineering degree?
Honestly, the having the internships in between were really big, because you go to college and you're working, you're doing all this mostly in the classroom work, right, and stuff, and it's like, oh, this math class is not really that interesting, and it's not exactly easy. So having those internships in between actually is kind of nice. It breaks it up. It gives you a little bit of that view for the light at the end of the tunnel of, okay, well, here's what your real job might be like, and getting to then see some of the things that come out of it. So, getting to see machines get built, getting to see, obviously depending on the internship, it's going to vary drastically. But, getting to see that's a big motivation. And then, just kind of keeping that light at the end of the tunnel, knowing like, hey, once I get done with this, I get to go have a job where I get to design cool equipment every day and get to see this stuff and reap the rewards. So, that's why I always just kind of kept thinking too was, light at the end of the tunnel. And then those internships were nice, gives you a little sneak peek, as you're in college. So. Yeah.
Thank you. And how about you, Trevor? What keeps you motivated to keep pursuing your engineering degree?
Well, I'm going to see if I can talk into my mic so it still wants to show Jacob's face.
There, I can mute mine if you.
There we go. So what kept me motivated in college? Well, I think, like I said, when like Jacob said, remembering why I'm there, and I don't necessarily mean the why of, man, this is real professional here. And I don't mean just the why of wanting to become a mechanical engineer. It's, I'm there to learn and to grow as a person. And because I want to become, pursue a career, become something other, that makes a difference. And that was what motivated me. And that just happened to be engineering. And I think, I studied space flight, and I thought I was going to go work for NASA, or I wanted to go work for NASA. And then I ended up working in agriculture. And I have to say that agriculture is every bit as fascinating as the stuff that they're doing in space flight in many ways. And I think that's something that surprised me, is that as you get older, you realize that there's actually a lot of interesting things going on in all kinds of different industries. And so it's probably more important to focus on who you want to be as a person when you graduate. And in my case, I wanted to be a person who solved problems and was good at their job. And, the specifics of what kind of a mechanical engineer I was going to be was a little less important. And I think that's probably what motivated me. Now, that's not to say that's what motivates everybody, but that's what motivated me.
Wow, that's so interesting. And kind of going on motivation, what is your favorite part about engineering? You might have already mentioned it, but take it away, Trevor.
Well, my favorite part of engineering is probably, like I said before, solving problems is a really big part of what we do on a daily basis. But I like seeing those problems solved on a grand scale. There are engineers who work in certain types of. There are engineers who work in almost every industry you can think of, right? And sometimes they will solve problems for a customer and they'll never actually see it. It's never something tangible that they can go out and look at. But for me, for example, we've designed machines that make life for farm workers much more ergonomic and safe. And so to go into the fields and see the working conditions improve and see the farm workers happier and getting injured less, that for me is really, really quite special. And I really enjoyed that.
How about you, Jacob?
Yeah, so definitely getting to see the machinery come to life. I'm sure I've probably mentioned it already once. That's the biggest motivator for me. Also, I get to have the extra benefit of being a farmer myself. So I work on the kind of things that I use at home. So kind of getting to be on that forefront of technology through work, and then getting to kind of transfer that to my own personal, life can be really kind of neat sometimes. So to get to, not only get to see the machine run, but then also be using some of that technology and equipment that I design at work at home is a pretty neat one, which is pretty, specialized. Not a lot of people, work and their hobbies are in the exact same field, quite lined up that much. But yeah, so that's a big one for me, just getting to see the technology, getting to see the machines come to life, all that is definitely very neat.
Yeah, thank you, Jacob. And on the note of favorites, someone in the chat asked, "What is your favorite GK machine overall, or your favorite type of machine?"
So for me, a lot of the equipment I work on is of our own line of equipment. So we build a lot of sprayers and fertilizer spreaders, and so I've been doing a lot of work on that lately. So probably one of those would be my favorite. I'm not sure if Trevor had ran you guys through some of our machines, but the TR6, it's a track sprayer. They use it on a lot of specialty crops in California, Mexico. We shipped one to Ohio here recently for a nursery. They're all over the place. It's a very specialized machine. Really, there's no other competitors that build exactly what we're building. And so it's kind of neat. It's that niche market. It's been adapted to do a lot of different crops as time's progressed. We've been building it for probably 20 to 30 years. And so it's pretty neat. And almost every customer that comes to us is doing something different. So with that particular machine, our base machine is pretty standard, but then every attachment for the most part is custom. And so that's probably one of my favorites, just because it's a machine you got to go through redesign, new engine, and then getting to constantly be, how can we make it work for this? Or, oh, this customer's doing this and we've done this kind of similar thing over here. What can we do to make that work for them? So that's probably one of my favorites.
Wow. How about you, Trevor?
Well, one of probably my favorite machine, to be honest, is a machine that I was a project manager for. So that makes me a little bit biased, of course. But it's a machine that basically it cuts a particular type of vegetable, strips the leaves off, bunches the vegetables together for people to ban them, and they package them on the machine, put them in boxes on the machine. Then the boxes are conveyed to an area where they're put on pallets on the machine. And then finally, you have a stack of boxes ready to go to the supermarket on the back of the machine that they get pushed off and onto a truck, basically, ready to go to the supermarket. And so for me, I that's my favorite machine, because it's sort of a one-stop sort of, from when it cuts the plant to when it's actually going on to a truck that will haul it off to a refrigeration center for transport. It's all one machine. And that concept of doing everything in one machine is really cool to me. And the fact that to make that happen, we had to use tracks, hydraulics, electrical systems, control systems. We also did a lot of mechanical control stuff that didn't use electronics to control things, but used different kinds of mechanics and linkages to do things, and conveyors, and so like all these different types of engineering that had to stack up to make this machine. Sort of that combined system is, I find, very fascinating when you have all these things integrating together.
Thank you, Trevor. And kind of talking about projects and making these machines, what is your favorite part about the engineering process? How about you, Jacob?
So, well, personally, my favorite part is, it's actually, that's kind of tough. It'd be either probably when you're in the kind of initial design. You're trying to come up with some concepts and figure stuff out. You're kind of spitballing ideas. That's that. And then once you're just about got the machine together, you're doing, testing, your problem solving, figuring out, oh, this part doesn't work. What we're going to do, kind of the crunch time, working down with the guys who build the machines on the floor. Probably one of those two. I don't know if I could say which one's my favorite for sure, but definitely one of those.
And by now, if you haven't figured it out, I'm kind of a people person, and my favorite part of a design project is that team interaction of sort of being with the team to solve problems. That's something that really gets my juices flowing.
That's awesome. So we have about 5 minutes left. So if any of the students do have any last minute questions, this is the time to put them in the chat. Thank you so much, Trevor and Jacob, for letting me interview you. And I guess one last question. Oh, I see we have one. It says, oh, Kellen asked, what is the hardest part in the engineering process?
Jake will probably have a good answer for this, but I'll say the hardest part has always for me, has always revolved around communication and making sure that all of the assumptions you're making are correct and that you understand all of the constraints that you're dealing with. So you might have an understanding of what you're trying to build, the goal that you're trying to achieve, but you oftentimes, when you're starting these projects and even all the way up until you've built the product, you don't always understand all of the constraints, the environmental conditions, the different things that may inhibit you from being successful with a particular design. And sometimes you don't get told those things. Sometimes you have to make assumptions, and that's probably the hardest part for me.
How about you, Jacob?
Yeah, I'd say it kind of relates to that. For mine, I'd say is having, you have to really have a broad understanding of what the machine that you're going to be designing is and what it's doing and how it's going to be operated and the people who are going to be operating. Because a lot of the times, we're working through multiple levels of communication where we work direct with customers on big projects and special things, but a lot of it, we get our information through a salesman or maybe even another engineer who's talking to maybe, it could be someone who at the customer's end, you might be working with someone who's like, just basically buys things. And so they don't really know what's going on, or you might be working with the company owner or a manager or who knows. And that's typically not going to be who's actually using the machine. Sometimes it is, sometimes it isn't. And so actually in some of those people, they'll have a really good understanding of what their guys want, what their guys do, and what the machine is to do. But a lot of times they don't, and they don't take these things into account. So then you never find them out. And so having a good full understanding of the whole machine and how it's going to be used, and then also back to having a good understanding of your machine you're designing, is not backing yourself into a corner, especially when you have a lot of different systems. That happens, because you'll have a lot of different engineers working on it, usually specialized in things. And so the mechanical guys will kind of go through it, and then the hydraulic guys get through, and then you get to the electrical guys and they start looking at it and they're like, hey, this isn't going to work. We can't put our components in here. Or, this spot's not going to work for this, or these two things are too far from each other. And so you really have to keep in mind, the big picture. And so all these systems can work together because it's really easy to back yourself into a corner if you just kind of get in that single mindset of, oh, this is the problem we're going to address. We're going to design for this. And you don't think about these other things that then they get built, or the other next engineer gets to it. And then you have to go back and redesign and try and fix those things. So that's a pretty tough part, but it's all manageable. It's all things that every project you do, you learn a little bit more. You make some mistakes. The next project, you don't do that. And so every machine, you're constantly getting better at these things to the point where then it's not so much of a struggle. So.
Yeah, that's amazing. Just hearing about your engineering process. And it looks like we have time for one last question. And my question to you is, what advice do you have for aspiring engineers?
So I'd say just, keep on it, work hard, get experience, don't be afraid. It's really easy to want to hold out for the perfect job, right? Or the perfect opportunity or the perfect thing. And sometimes, you can't do that. You might be, well, you need a job and this is the job there is, so you're going to take it. Or maybe you're going to take it in this industry. And even though it's not really what you're the most passionate about, you're still going to learn a lot. You might find out that you like it better than what you had originally thought. Or you might say, hey, I worked here 5 years. I've learned a lot about these other things. Now I'm going to try and find a new one, and I'm going to reapply those things, and I'll have that, good experience that a lot of other people won't have because they didn't work in that other field. So, don't be afraid to take opportunities that don't at face value seem like they're going to be 100%, but they might end up being extremely valuable. But yeah, work hard. Schooling can be tough. A lot of those classes can be tough. Hard to see the light at the end of the tunnel. I've been there. We've all been there. When you're in that calc class or linear algebra or whatever it ends up being. But there's a light at the end of the tunnel. You get to your job and then it's all worth it. So.
And I'll follow up with that by just reiterating again that, it's more important that you're skilled at a number of things, that you've got good communication, you're a good team player, all these different things, more so than you got an A in a calculus class, right? The whole person is more important than just the good grades, right? But my advice can kind of be summarized in some bullet points, which is be willing to change your assumptions about life, about your career, about yourself, about the projects you're working on. Be kind, be brave, and be curious. Always be learning, regardless of whether you're in college or not, and make a difference. Those are my bullet points. So.
Thank you so much, Trevor and Jacob. I learned so much, and I will definitely be keeping that advice in my pocket. Thank you so much, students, for attending this webinar. And I think that's it. We will be wrapping it up, and thank you so much.
Well, thank you, Leslie. This was a lot of fun.
Yeah, thank you very much.
Yeah, thank you. Great job, Leslie, facilitating this. We appreciate it. All right, you guys have a great weekend.
Yep.
All right, bye.
Bye.